So you see that the earliest dam in Mesopotamia is 6000 BC. And also this is the the oldest dam currently in Anhui province. It's Anhui Reservoir in 591 BC. And you know this is the Kula dams, and also the first hydropower plant is in New York State, in the United States. And damming is also the most significant anthropogenic activities of hydrology. So we know all the global dams impact about 27.3% of the surface runoff. And if you count about large dams, like the damming height higher than 50 meters, right now it's over 60,000. But for ponds, little ponds, it's more, 16 million. And also if you think about the ocean terrestrial to the oceanic transport, the global damming impacts about 20% of carbon, 40% of nitrogen, and 70% of phosphorus retained in the reservoirs. So that's a big amount. And also in China, there are approximately 100,000 dams in China, and over 50% are along the Yangtze River. So you see that this is the Yangtze Three Gorges. Chongqing is right here. Chongqing is right here. Chongqing is right here. So you see in the upper of the Yangtze, we have a lot of plots. And it provides almost 2/3 of the Chinese installed capacity of hydropower. And all these dams provide multiple services for well-being of humans, like flood control. That's the primary function for the Three Gorges. Three Gorges is not primary for hydropower production, but primary for the protection of the downstream towns like in Wuhan, Nanjing, and Shanghai. And also the food supply, hydropower, navigation, this is where you go yesterday, and also the recreation. So dams have various functions. And we still have to know about the effect of dams in reservoirs after damming. So we just categorize in 4 aspects. One is the flooding aspect. You know that if you build up dams, you flood a part of land, and if you flood it, organic carbon decomposition, and also the nitrogen or phosphorus, other nutrients released from the flooding of dam. And also dams are barriers to stop the sediments. So I don't know if you think about the sedimentation or sediment trap effects in the Three Gorges. Anybody has the idea of this? And also, for instance, the barrier will increase in the dams. And we also see that the reconstruction of the aquatic ecosystem from the Nordic one, a running type ecosystem, to a lentic type, to a lake type. So this is why Professor Muhammad told me to analyze the water parameters, the hardness of this one. And the reconstruction will change the aquatic chemistry and also the consumption. You will see that from Chongqing to the Three Gorges, there are a lot of towns around the reservoir. And it's like a collector of all the non-point and point pollution or kind of anthropogenic activities can impact those pollution loads in the reservoir. So it's amazing for the China Three Gorges Reservoir that a reservoir holds about 20 million people living in the reservoir. So right now our wastes are all going to the Three Gorges now, but after treatment. So one of my research aspects, I think 70% of my research is related to carbon emission due to such kind of effects. But if you think about the carbon emission, it's not a big deal in global scale. You'll see that this is IPCC Assessment Report 5, that the freshwater outgassing of carbon dioxide is only 0.3 petagrams per year carbon per year. And comparable to the fossil fuels, it's very, very small percent. So it's not a big deal. So damming accounts about 10 to 15% of freshwater outgassing. And it's negligible compared to other anthropogenic activities, for instance, like the fossil fuels or net land use change and some others. So global reservoir greenhouse gas emission for carbon dioxide is about 12% of all fresh waters. And methane is about 0.10% or 50% of all the fresh waters. For natural oxide, we don't have the graph data right now, it's a little bit large uncertainties. And the damming can create greenhouse gas emission. This issue was initiated in the early 1980s. There's a book published by the Canadian researcher named The Microbial Processes in Reservoirs. And they invented the word like trophic upsurge, which means that during the first years of dam flooding, there will be kind of primary production upsurge after the early few years of flooding. And after that, in 1993, both the Brazilian and Canadian researchers published a paper on, two papers on different journals. One is Ambient, the other one is Hydro. They question the cleanness of hydro. Because we think about the hydro is clean. Because when the water transport through the turbine, there's no emission comes. So right now, almost all countries regard the hydropower is a zero carbon hydropower. But it does not mean that the life cycle of the hydropower is clean because it flooded. It tried to, like a barrier to create an OC barrier, and also the reconstruction of the aquatic ecosystem as well as the consumption, other aspects. So they question the cleanness or zero carbon properties of hydrogen. And they experienced a 10 years decades of debates, like the discussion between the two Brazilian groups, Fernandes and Rosa, and other NGOs, for instance, like the IR, the International River Networks, and also WCD, World Commission on Dams. They published series of publications. And after, in 2006, the UNESCO Congress in Paris initiated a research program with the International Hydropower Association, and there are two phases. One phase is technical guidelines and risk assessment tools for evaluation of the greenhouse gas emission potential of that. And the second phase is evaluation of the net effect and the life cycle assessment. And also IEA and IPCC, they also initiate different types of research program internationally. So I was getting involved in 2009 after my graduate of PhD, after I obtained my PhD. I get involved in this both program in 2009, and IPCC I get involved in 2017 as a contributing author of the National Greenhouse Gas Inventories in the flooded land. So, and these are the general background. But the worst case is two dams. The first dam is Tucuruí in Brazil. Tucuruí is, they estimated that their gross emission of Tucuruí's dam is higher than Sao Paulo's annual emissions. And also approximately 3 or 4 times higher than the same hydropower production with fossil fuels. So this is amazing. And the other one is Albina. Albina is regarded as the worst hydropower ever because the flooding, these two photos are from the website from the Albina. It's large areas of flooding, but very shallow water head.
Where is Balbina?
It's still in Brazil, in Amazon region. So after the flooding, they estimated that Balbina, the gross greenhouse gas emission is 20 times higher than fossil fuels with the same electricity production, which means that this hydropower is exactly not clean. So these are the worst case ever in the world. And you'll see these are some publications from the World Commission on Dams and IRN, International River Networks. And also you can find this picture on the web is that there is a lot of money export, but a lot of carbon emission in the reservoirs. So it's interesting. So some NGO, some non-governmental organizations reported that hydropower is dirty and is a harmful form of energy production. And even FCCC, I think everybody knows this. United Nations Framework on Climate Change Convention, and also the CDM means a Clean Development Mechanism. They illustrate that hydropower density, which means that this unit is the installed capacity divided by flooded land. So per installed per flooded land, per square meter of planet and how much installed capacity is there. They divided three different categories of hydropower projects. One is that if the hydropower density is lower than 4 watts per square meter, it's unacceptable in the CDM, which means that they have the potential to emit a lot of carbon emissions. And if the higher, it's negligible. So can anybody know what is the hydropower density in Three Gorges? Does anybody knows that? The Three Gorges Dam, the hydropower density is 25.6.
Wow.
It's higher than 10.
So it's,
25.
so it's acceptable.
Yeah, it's acceptable. But they have some other issues. I will talk a little bit later. For instance, fish or some other things. So China has been experienced tough time during in 2009. You see this one. You can still find this news in the Nature. It's published by Jen Chu. It's the Chinese dam may be in 10 minutes. And it's originally cited from a paper discussed about the methane emission after the flooding of the new reservoirs. And it published that there are a lot of methane emissions. And so they cited this paper and talking about the Chinese dam maybe in 10 minutes. So this is the start point of my research after I obtained my PhD. And we can initially make some judgments. We don't have any data at that time from 2009. We don't have any data. But we can have some of the evaluation on this paper and this news that carbon emission in reservoir drawdown area is as high as tropical reservoirs. This paper discussed. And also, it has a mistake. It extrapolates the on-site measurement to the full reservoir. This is a flux, but it extrapolated. From one side, they take measurements and they see a very high emission, and they just blast the whole reservoir area. So that's unreasonable. So you can still find this paper. And also, it regarded as the historical land use and the effects of the reservoir economy. These are some mistakes in this paper. So starting from that time, we try to think about how to make any analysis or research on the Three Gorges Dam and research. And this is a land use change over the past 30 years of the Three Gorges Dam. So we find this is the dam site, which is this one here. And also we have some different types, and it shows the land use change. And here are the,
will you share with us this presentation in paper?
Yeah.
Thank you.
And also here are some parameters of the dam body. I think you know this. This is you get familiar. You don't know?
Yesterday we.
I think yesterday
We discovered.
Sorry?
We discovered this.
Okay, you discovered. You are all scientists. You explore this and you do research on that.
We were asking.
We have the turbine, 32 turbines. On each turbine is 700 megawatts. And I have a photo of the turbine, the power factory there. And the draw line is there is the fastest change. And sorry, I don't think that it goes well with this one. And the Three Gorges Dam construction is not the modern Chinese dream. It's after the Qing dynasty. The first man who initiated this project is Sun Yan-tse, originated and envisioned by in 1919. Just after, 8 years after the end of the Qing dynasty. And in 32, the preliminary work started. And 44, during the World War II, the survey and reported by the general plan by the U.S. Bureau of Chief Designer John Savage. So this then the location is pre-selected by the U.S. It's kind of USGS right now. USGS right now, and U.S. Army right now. It's kind of the U.S. Army engineer, and at that time it's called U.S. Bureau of Climatization Chief Designer Engineer, the John Savage.
Sorry, why it was initiated at that time by the U.S. Army?
You know that this was, Sun Yan-tse is currently, we call it the father of maybe the modern China, because he led the Xinhai revolution to end the Qing dynasty. And after that, they have big ambition to build a modern China after the end of the Qing dynasty. And during the old government of Chinese government led by the Kuomintang, and they set up some preliminary plan. How they are big projects, and what's the planning of the whole country. And during the World War II, you know that China has very close relationship with the U.S. They try to support us, and also they try to recall the big projects initiated by the Sun Yat-sen and ask the U.S. engineer to come to China to help to make a preliminary design. But this preliminary design is based on that time, data and based on the data and technology at that time. So it's very preliminary. You just think about the experience in the Hoover Dam, because you know that Hoover Dam is 1930s. So they make such kind of designs based on, at that period, the close relationship between the Kuomintang government to the US government. And also they try to initiate, they are thinking about after the World War II, we are starting some infrastructure investment or something like that. But you know that in 1949, the new Chinese government is set up. And also the government leader, our chairman Ma, calls for the project, recalls for a project to control the floods downstream of Wuhan and Shanghai and Nanjing here. And you know that in the early decades of the new Chinese government, we are still lack of money, lack of engineering experiences, and also lack of technology. So this giant project postponed to 1980s after the revolution or cultural revolution. And then the project started to design an EIA, environmental impact assessment. During that time, there are two groups of China. One is from the Ministry of Hydropower Engineering, and the other is the Chinese Chemical Sciences. Two independent groups, the scientists, doing the EIA, environmental impact assessment, and also separately doing the feasibility report of the Three Gorges Dam. And it takes about tens of years. And even there's another pilot dams, or right now it's still a very big hydropower project, which means in Gezhou Dam, 32 meters downstream of the Three Gorges Dam. It's a river runoff hydropower project. And this hydropower project is finished in 1984 as a pilot project or demo project for the construction of the Three Gorges, because both of them are concrete dams. So in 1992, all the project is approved by the National People's Congress. And this is the only one project approved by the National People's Congress. And in 1997, they blocked the Yangtze, and 2023, 20 years ago, they start the initial impoundment of the Three Gorges. This is brief history of the China Three Gorges Dam. So you see one here. So you see the geology of the China, we have two steps. One is the Tibetan Plateau. So you see this is multi-stone.
Yeah.
It's right there.
Yes.
And this is a Tibetan Plateau, and also the other one is the second step, it's right here. So the Chongqing, Wuhan, and Shanghai, and this is Beijing. And right here, they block the second stage, according to the whole geology of the Yangtze Dam right here. So you see here is the second stage. So there's a high mountains, and Chongqing and Chengdu are in the basin. It's a plain basin. So you see Chengdu is very flat. It's right here. It's surrounded by the mountains. They are surrounded by the mountains. And the operation strategy of the Three Gorges Dam is like this. In May and to September, it kept at the low water level stage, about 145 above the sea level, to keep the floods. So that's why I told you that you mentioned that 22 square kilometers. I'm sorry, cubic kilometers for maintaining the upstream floods. And in drought season, the water level goes up from October to April and kept at the high water level stage over the 160. The highest water level is 175. So this will be for the drought season for hydropower production. And even when there is a spring drought in the downstream, they hold a lot of water to help the downstream to mitigate the spring droughts. So you see, after this type of operation strategy created about the reservoir drawdown area like this, I think you see some drawdown area. But yesterday, the water level I checked online is about 170, 148, I'm sorry, 160, around 160. So you see that the total area of drawdown, seasonally drawdown area, is 380 to 400 square kilometers. It's a huge one. And we also did this kind of area zone. So these are ecosystem response after the reservoir impoundment, something like that, reservoir drawdown area. And these are large ponds near the Yangtze. So I think this is evident in the little three gorges. You see this one, and also you can still find near the coastal city where you go. It's a little bit flat, but seasonally flooded. And also in some tributaries, during the initial impoundment, they have some kind of algal blooms in tributary backwater area. For instance, like these are the algae blooms from the dinoflagellates, and these are cyanobacterial blooms. For instance, these are Anibena, and also we have some kind of dinoflagellates and a mixture of cyanobacterial blooms, and these are microcystic blooms. So all these are the consequence of ecosystem involvement after the three gorges. So who is trying to use my voice? Huh? 你在用我的这个吗? Where is this voice comes from? Oh, sorry. I think this is from my private. It's a slide from the webinar. From the webinar, but somebody recorded. Yes. And we initiated the field sampling program in 2010 after the report in 2009. This is the first sampling campaign along the whole three gorges for the greenhouse gas emission and also for other ecosystem parameters. And during the first sampling campaign, and also you'll see that the first impoundment is this is the water level of at the dam site. In 2003, it starts the impoundment, and then it maintains at around 148 to 145, a very minimum variation. And in 2007, it goes to 156. And in 2010, the first time it goes to 175. All the primary impoundment progresses in the China Three Gorges Dam experienced 10 years, from 2003 to 2010, 7 years. And we started the first sampling campaign in 2010 to 2011, and also from 2015 to 2017. And we optimized the sampling sites here. You see, the sampling sites are already optimized. And we take the samples in the air water diffusive. Sorry, just get that. Yeah. And we take some air water diffusive on the mainstream, and also the equilibrium emission in the shoreline area, and also we take some samples in the reservoir drawdown area. And this is at the heart of the turbine house, the turbine house of the dams and the gases to measure the gases emission. And according to this, we divided the upper part in Chongqing to Fuling, those towns right here, Fengdu. You'll see that the difference between the water velocity and the hydrological condition is totally different. The first one you'll see, this one is kind of like a natural river. It may be flooded two times in a year. One is the natural flood, the other one is the impoundment of the 175. It goes back to Chongqing. This is why we were in the last Tuesday to the riparian that I explained to you that it experienced two types of flooding of riparian zone. And in the middle reach, from the ghost town where you have been to the Fongjie, and you will see it's a transitional area, transitional from the river to a lake. But if you go downstream, like the little three gorges, you'll see the little three gorges right here in Wushan. It's like the coastal zone or lower part of the three gorges. So, and here are some data. Here are some data for the methane emission in the mainstream and the main stem and the tributaries of the three gorges reservoir.
Jalil, would you please go back one slide? So the area that is light violet, like the Kaijan and the
Kaijan,
and the Wushan, the extremity of it. So originally, were they these areas tributaries, small tributaries of the Yangtze River, and with the initiation of the Tigor's Dam, they became more inundated and they became lake.
Yes.
This is how they. Okay, so there was originally like some kind of rivers there, and then they became.
Yes.
Okay.
Yes. These are tributaries. And actually, this tributary is still large. And also, the little three gorges, the tributary is around 5,000 square kilometers, the watershed of the tributary. And this is the Xiaojiang, and we call Anxi River. The watershed area of this tributary is 5,200 square kilometers. Comparable to the Yangtze, it's little one, but compared to others, it is still large.
Okay.
So you travel from Chongqing and travel about 700 kilometers to the dam. So you all see the full reservoir, what it is. And then here are some data. And over the past decades, we see some methane and carbon fluxes they are positively related. And hydrological control and sediment input may be among the primary source for the carbon dioxide and methane emissions. And also, we made some linear regression data sets in the mainstream. And also, for tributaries, this regression are weaker, and eutrophication and algae blooms will be the primary impact factors. And also, you see the limnological features. You'll see that for the hot zone, for the descent, you'll see like this. This is winter, and this is the summer. You'll see red in Fulin and Zhongshan, those are cities where you have Phoenix right here. And in winter time, we see some kind of hot zones of methane. And in summertime, the red one goes a little bit, which means that it's kind of the tidal effect due to the water level up and down. So it may move the hot zone of methane a little bit upstream and then goes a little bit downstream during the summertime when it's flood. And also you have no stratification of carbon dioxide, no hypoxia, but a little bit weak, very weak, dissolved of oxygen stratification. And also the thermal stratification is a little bit weak, but not significant thermal stratification during the summertime because it's running fast. The hydraulic retention time of the Three Gorges Reservoir is around 25 to 30 days. 25 to 30 days. And also we integrate by remote sensing data. We have a large remote sensing data and integrate different sampling sites. Because we take samples at different sampling sites. And we know the water surface area of the Three Gorges and we just integrate them. And then we find that it's about 100 to 140 1.4 to 1.4, around 1.4 teragrams per carbon dioxide equivalent per year. And it shows a slightly decreased trend of carbon dioxide and methane.
Why? Like adaptation?
I will explain a little bit later. I'll explain. So if you calculate the different pathways of greenhouse gas emission, you see that air water diffusive is approximately 70 to 80% in the gross emission. And we think about the riparian zone, the reservoir drawdown area is around 20%. And also the cumulative emission, degassing, or downstream reaches emission, they are very, very little. It's hardly less than 10%. So large part of gross carbon emission in the Three Gorges Reservoir is from the air water surface diffusion in both the main stem and the tributaries. And we compare to the global data sets. This data was coming from several publications from the 2011 to 2015. And you can see that comparable to global data sets, this is the median value for the Three Gorges Reservoir. And this is the global data set. It is a little bit higher. For the carbon dioxide emission, the Three Gorges Reservoir, the carbon dioxide emission is a little bit higher than the global data sets, the median of global data sets. The quantile is around 70%. But if you think about the methane, it's very low. It's less than 10. Normally, right now, we find a comparable to the global data sets according to the quantile. It's about 8%. Very, very low. So, and after that, we try to think about how to evaluate the net. Because the gross emission doesn't mean anything. You have to think about how many emissions it used to be. So the net effect, with the International IHA, International Hydropower Association, and IPCC, we proposed the conceptual framework of the net carbon emissions due to damming. The net means that the post emission after the damming, the post impoundment emission, excluded by pre-impoundment emission and excluded by unrelated anthropogenic sources. What do we mean by unrelated anthropogenic sources?
Like natural ones.
Like if you pee on the reservoir, that's unrelated, right? Because the anthropogenic activity, for instance, like the point or non-point sources, may create an extra emission in the reservoir. So you have to exclude the pre-impoundment, and you also have to exclude the unrelated. So if you combine these two green parts, it's kind of a visual baseline due to damming of emission. So here are a map of this is pre-impoundment before the impoundment, and this is the post-impoundment, which what we mean the gross emission, and these are the baseline. And the differences between the baseline and the post-emission is the net. And current limitation for this evaluation is like this. We have to define the system boundary. The system boundary, are we thinking about the whole watershed or the reservoir surroundings? So what you see is the reservoir surroundings, but what you don't see is the whole watershed. The China Three Gorges Reservoir has 1 million square kilometers. It controls 1 million square kilometers. It's a large and huge watershed. So this is system boundary. How to define the system boundary? And the second thing is that you have to set up the causal chain. You have to identify what and who contribute to the net. And the third one is that dynamic inversion and prediction. What is the future? You have to think about the life cycle. So what I'm going to talk is to this. And we are still working on this. This is not a current research outcome, but we are thinking more on this. So in 2017, we started a evaluation strategy for the Three Gorges evaluation of net. The first one we divided into two parts. The first part is the flooded land. Sorry, this two should be those here. The flooded land is 332 square kilometers. And we use the IPCC strategy to evaluate the terrestrial, carbon seep, and the CO emission from different land use. And also for the air-water emissions, we use the 2D hydrodynamic model and the methane empirical model. And we use the MIC ecolab. And the baseline year for the pre-impoundment is 1998, where before its impoundment. And also the quality model and the surface, we make some innovation and make some revisions of the biogeochemical processes, and it can estimate the carbon dioxide. Because we don't have any historical data, we use the data of TA, the total alkalinity data, to estimate the carbon dioxide. And also use some data on the methane emission based on empirical model. It's a linear regression, very linear regression. And here are some land use before the impoundment. We don't have kind of this data, but finally we find the data source. It's a year ago before the construction of the China Three Gorges dam. Because the Chinese dam have a large activities of the pre-impoundment clearance. So when they do the pre-impoundment clearance, they have some kind of data of what kind of the land, of croplands or some different types of land, and they have kind of data. And we compilation the land use, we rather than according to the IPCC consistent representation of lands. And here are some photos before impoundment. These two towns are the little Three Gorges where it used to be. You will see the historical map. This is the place of the little Three Gorges. Yeah. This is also a Wushan town. And you will see it's after the department you are living. I think the middle three goes here. So, according to IPCC, we made some assumptions. One is the steady state. Because we don't have any historical data, we make the steady state and non-conversion during the past 20 years. And also, we are not considered the spatial engineers because we don't have any satellite map at that time. In 1994, there is no satellite here. So, spatial engineers are not considered. And pre-impoundment clearance are not considered. So, after this assumption, it made us feasible to evaluate the biomass above the ground, biomass below the ground, soil organic carbon, and that organic carbon in different types of land. And for the estimation of methane emission in different land use, we use different kinds of data and also the possible range. And we make the Monte Carlo analysis to find the higher possibility range after the evaluation. And for hydrodynamic modeling, we in the mainstream and the tributaries we make a lot of grading data and we evaluate the 14 large tributaries of the Yangtze irrigation. So I'm going to skip this a little bit quick. And also you have to evaluate the unrelated anthropogenic sources. And we evaluate the regional point and non-point pollution in 1998. So here are the watershed in the reservoir surroundings that impact what we call is the reservoir region, which means that here, the red line is the reservoir region. We cut the different cross section. One is the downside, the other one is the bay. But here, there is another large tributary above the bay. We cut it, and also the other is Wu River. It's a large tributary, and also this is upstream of the Yangtze River. So we cut the four cross section and made it as a watershed area. We call it a Three Gorges Reservoir region. And all in the region, we evaluate the point and non-point source pollution in the region. And we summary of annual pollution loads in 1998. We evaluate CO2, ammonia, total nitrogen, and total phosphorus, etc. And for biogeochemical conversion processes, the carbon dioxide historical data we estimated from the history TA data because TA is successful, the total alkalinity is successful. And also we make some conversion. We neglect or we assume that benthic vegetation is not important. You don't see any benthic vegetation there. And also the zooplankton is not considered. So the gray one is not considered. But we consider detritus, phytoplankton, sediments, and inorganic nutrients. And this is the whole biogeochemical conversion processes, and we divide it into carbon, nitrogen, and phosphorus, divided by 3 elements. And also here are some calibrations. We calibrated the water surface area, evaluation, surface width, surface area, different kind of evaluation with the downstream and the river flow. So for hydraulic modeling, it's easy to obtain such kind of evaluation. And these are the data from the different types of land use before the impoundment. And after that, we can find that the pre-impoundment emission is around 320,000 tons carbon dioxide equivalent per year. And if you think about the post-impoundment, the net is around 100,000 tons per carbon dioxide equivalent per year. So it's not as high as estimated. And we make some scenario analysis. Here are some scenario analysis. We think about, we try to set the zero scenario, which means that if there is no pollution, no people living in the reservoir, no pollution in the reservoir, this is a 0. And we also 1998 scenario and 1915 scenario, the different types of scenarios. And we find a mass balance approach between pre and the post. In pre-impoundment is 1998, post-impoundment is 2015. And we make the comparison between pre and the post. And all these information get together, we find that for flooding effects, it's around 20%. 20% of the net greenhouse gas emission are coming from flooding, only 20%, not all. And for the consumption in the surrounding communities, in the reservoir area, it's not a big deal. Although we try to hypothesize that there is a large amount of people living within the surrounding communities, but comparable to the whole watershed, the surrounding, the point and non-point pollution due to human activities in the surrounding community of the Three Gorges reservoir area is not so important. It's around 1% contribute to the net greenhouse gas emission. And but the barrier effect, what does it mean by barrier effect? It means that it like to stop all the upstream organic carbon comes in the reservoir, settle down. This is the barrier effect, around 50%. Around 50%. And also reconstruction effect is around 30%. It's like the riparian zone. You see, I think yesterday, during the 3 days ago, you will see that the riparian zone is all green, turns out green. But if you come here in April, when the water level goes down, all the riparian zone is soil color. It's gray or some other soil color. So it means that the vegetation recover can exist and very strong during the 5 months reservoir drawdown. So you see that right, the riparian zone, the reconstruction, and also in tributaries, the primary production due to the decrease of the water velocity can create the primary production. And this kind of what we mean the reconstruction of the aquatic ecosystem can contribute to around 30% of the net greenhouse gas emissions. So here are some clues that unrelated human sources in surrounding community was not a big contributor in the net greenhouse gas emission. And internal sea, for instance, the barrier effect and reconstruction effect, they are the sea turnover in the reservoir may be very, very significant. So, and as we try to evaluate like this, you will see this new picture. I think you already see this one.
Yes.
Yes.
Yeah, the Peach Mountain.
Yes.
Yes.
Yeah. So you see this is before. Before it's like this. After. So you see that?
Yeah.
So this difference. And we make the comparison between some kind of water quality parameters. And we will see that right now it's cleaner. When the water goes clean, algae, primary production, comes out. And it can cause the change of carbon emission. And when it goes here, there's a lot of muddy and a lot of sediment transport. So it is kind of differences. So after that, we try to develop the life cycle carbon emission. This is not published, to be published by one of my PhD students. We use the Earth system model and the base static regression trees. And also you see the life cycle simulation after the different social SSP scenarios. All the right name. So you see for under the climate change, the different scenarios, the carbon dioxide will gradually decrease, but the methane will rapidly increase. And also we set up models in the long term carbon emission of primarily contributed by the sedimentation. This is another reservoir we published on water research. You'll see that the flooding effect quickly goes down. The reservoir can consume the organic carbon very quickly within about 10 or 20 years. This is another reservoir in upstream of Yangtze. It's called the Shangjiaba reservoir. You will see a video later. And you will see that in different scenarios, there will be a decrease of methane. And after that, if the reservoir collected several of sediments, and the methane concentration in water column will gradually increase after 80 years of operation in reservoirs. So barrier effect may be the most important effect to contribute to the net greenhouse gas emission due to the reservoir. So all these reservoir things get together, we have to think about the hydropower project, whether the hydropower project is green or not. So it's kind of different actually. If you think about the hydropower, it's a different size, different view. No direct emission when producing the energy, all are renewable. When the water goes through a turbine, it's not like the fossil fuels. So there is no greenhouse gas emission during the production of hydropower. But the life cycle assessment needs to think. And also reservoirs are infrastructure level. Not all the reservoirs are for hydropower production. All the other reservoirs are for the fish or water supply or other issues. And the reservoir greenhouse gas emission is a part of LCA. And if you think about the river runoff hydro, there is no reservoir emission. So it's totally different point of view. Don't get mixed in this. So you have the infrastructure, the dam, the reservoir, but the purposes is various, like the services, hydro, flood control, navigation, irrigation. So carbon footprint needs to be allocated for different types of services. And within this, we just carried out a global data set. These are from the global data sets of more than 200 hydropower projects. We collected and published data, and we made some regression. You will see that regardless of the system boundary, regardless of their methodology, the global data sets told us that the hydro has a mean of around 25 gram per carbon dioxide equivalent per kilowatt per hour. 25. Does anybody know how much for coral? How much for coral? How much for gas? For coral, it's 800. I will show you the data a little bit. And the range for the global data set is 0.04 to 237 grams per carbon equivalent per watt hour. For the first and the third quantile, it's 15 to 31. And if you think about the differences of types, river runoff type, reservoir hydropower, pump spot storage, no significant differences. We just regarded it of the system boundary and the methodology. And we set up our system boundary in Chinese 3-quarter strategy. See that with our system boundary means that all the life cycle of the hydropower project needs to think about the project preparation, because the Chinese dam has a systematic pre-impoundment clearance, and also the dam site preparation. And also in construction phase, you need like the material production, the transportation, the construction work, and installation. And all these consumes energy and consumes the material. And in operation and maintenance, not only the reservoir part, but you have to think about the regular maintenance, and also for the life cycle from the cradle to grave, the whole life cycle. I have to say that the 3-quarter dam may not exist forever in the Yangtze because they have their life. The estimated age for the 3-quarter dam is 150 years. But after that, considering the project, considering everything, considering the geology part, it may be removed, maybe decommissioned. So there is another decommission phase for all this kind of anthropogenic projects. So these are the 4 phases of the hydropower's life cycle. And we defined this as a system boundary, and we evaluated the life cycle assessment of carbon footprint in the 5 of upper Yangtze reservoirs.
I have a question there. Do you have any protocol to establish if you want to collapse the dam or rebuild another one? How is this going to be?
I have to give you another story. Right now, the U.S. are trying to increase the decommission of their dams, because a lot of U.S. dams is constructed before the World War II, after the Big Depression, during the government of Franklin Roosevelt in 1930s, in 1920s to 1930s. So right now it's 100 years.
Yeah.
So a lot of U.S. dams are in the decommission phase. So they remove dams. In China, the little dams, the smaller dams in the tributary or in some streams has a service age for about 50 to 70 years. And for the eco-environmental issue, they are trying to remove all the smaller dams. But for the large dams in China, all these large dams in China are built in the recent 20 years. So you mentioned that is there any protocol or something? Right now we have protocol of dam removal of smaller dams. But for large dams, it may be beyond our age, beyond our generation. We may let this question to our next generation.
Okay.
So we have to think about this. So after all the evaluation, we find that for the 3-quarter dam, the life cycle considering the net greenhouse gas emission is 22. For the up 4 is a little bit lower, a gram per carbon dioxide equivalent per hour. And the large share of greenhouse gas emission is uncertainty is the decommission and also the reservoir operation because it takes a longer time, 150 years. So they still have some other. And if you think about this, we just extrapolated our data, and according to the literature data, we find that the China's large hydro is 13 to 24 grams per liter per carbon dioxide equivalent per kilowatt per hour. And the global cases is 15 to 31, which means that the China's hydro is a little bit lower than the global hydro. And IHA's mean, IHA median, the International Hydropower Association median is 18. So China's hydro, from the perspective of life cycle assessment, it is still very low. And if you compare it to other, like for coral, it's over 1,000 kilogram per carbon dioxide equivalent per hour. For the oil, it's around 1,000. For the clean natural gas, it's around 800 to 900. And for the PV, because of the production and also the decommission phase, is around 50. For nuclear and also for wind power, the China's hydro is very close as wind power. Because wind power has a life cycle of only 20 years. They have to replace, they have to reuse other kind of human products. That cause life cycle carbon footprint. And for the PV, every PV plate has to remove every 10 or 15 years. So the construction of the plate, the PV plate, it still costs a hydropower carbon footprint. So you can see the different comparison about different kinds of energy. The CF of PV and wind are significantly higher than the Chinese hydro from the LCA. So for the policy for hydro towards China's government of carbon neutrality, the net effect of exclusion for the hydro and all renewables to evaluate the disturbance to natural ecosystem. The other one is that we still need methodology for all renewables because they have to think in the same methodology, the same logistic. And the carbon certification and carbon market needs to open for hydro and other renewables. And carbon industry towards the sustainable and ESG performance evaluation. We are now pushed forward on this. And the next one is the future perspective. This is a little bit large part. We have to think about back to our ecohydrology. We are thinking of ecohydrology right now, according to my personal perspective, is not means the nature-based solution. Ecohydrology, I have to say that ecohydrology does not mean equal to nature-based solution. Why we talk this? Nature-based solution is the solution, but ecohydrology has its original principles and has its original, like the biotar, the regulation between biotar and hydro. It has a broader ideas more than the solution itself. Ecohydrology research, ecohydrology technology, ecohydrology solutions can towards to nature-based solution, but it does not limit it to nature-based solution. We cannot make them as an equal thing. In ecohydrology part, we think about the multiple purpose, multiple space purpose, complex variables in open ecosystems. For instance, in the upstream, we talk about we may meet water, energy, and more. For hydropower, there is a water production, water energy production. For the water management, the ecohydrology side, you need to think about climate change, like these things. You need to also think about the dams operation and economy growth and population growth or population change. So environment, what does eco-environment mean? We need to think more. And we may, if the population grows, it may go to another side, that land degradation, pollution, and eutrophication to the reservoir. So it's a complex system, like the constraints and compensation. And what we just think about how the hydro company makes some compensation to eco-environment. But we lost any strategies of water resources management. So we need to think about adaptive management and also ecosystem sustainability. So you will meet the different stakeholders in the upstream of the Yangtze. We have the stakeholders of River Basin Committee. The River Basin Committee of the Yangtze, they have the right to set the River Basin Committee, they have the right to allocate the water in the different types of dams. They can tell you how many water of the 3 gorges dam release how much water downstream. They have the right to do this. And hydro company is a secondary stakeholder. They want to increase their economic benefits, and also as a responsible social responsibility, as a way to show their social environmental responsibility. They try to show, okay, I put a lot of money, I do a lot of effort in the mitigation of adaptive management. And also for local governments, they have to think about how to stop their pollution to the reservoir. And also the local citizens, they don't care about, they just need to think about, okay, if we have the water, our lifestyle totally changed. In this mountainous area, before the impoundment of water, all the people, or most of the people living in the upper mountains. But if they have the water service, their lifestyle change. They can get close to water, they can develop the water transportation, and they can have some kind of recreation near the water thing. So water is the best thing, but another aspect that they have to think about how to protect the water quality and how to protect the ecosystem. And also we can have other stakeholders like also local enterprises. In the Little Three Gorges and also in some other mountainous areas, they have a very large industry of phosphorus industry. And the phosphorus industry may release a lot of phosphorus into the tributaries and potentially create the problem of eutrophication problems. And in ecosystem concern, fish, the population restoration, right now, the whole Yangtze mainstream of the Yangtze and tributaries have experienced 10 years of forbidden fish. 10 years of forbidden fish, not only fish farming, but also fish collection.
Yes.
And also the water quality eutrophication and also the carbon emission.
Well,
So is there
Professor.
any trade-offs or any synergies?
I didn't get why is this forbidden to fish? Why?
Because the Chinese, the Chinese leader and all other Chinese scientists, they found that the population of fish and diversity of fish in the Yangtze mainstream decreased sharply over the past 3 decades. And all the decrease in fish population is mainly because of several complex issues. Damming may be the one reason, and one primary reason I have to say. And the other reason are the faster economy growth. And the third reason is that because of the fast economy growth and also the faster population growth, they make the overfishing.
And
Yes.
if the dam is one of the main problems causing the cleaning of fishing, why they don't build fish ramps?
They are trying to have to planning a fish ladder or the fish passage along the dams. But right now there is still other debates whether the fish passage is effective. Can you imagine? Or if the fish passage is kind of another infrastructure investment, and even the large infrastructure investment. And if this works, there's still a lot of debate. Right now, some scientists are proposed to build a fish passage near the Three Gorges Dam. And the investment of the infrastructure is tens of billions of US dollars or something like that. So it's kind of a trade-off between equality growth and eco-environmental benefits. So it's kind of a very hard for the government or for the top layer to evaluate the trade-off or synergy. And also, this is another note that for the concept notes of inclusive and intelligent innovation. This slide is what I made in this name. That innovation is the driving force driving in global progress towards the UNSDG. What we hear, you are all scientists, engineers, and governmental offices. We all need to think about innovation to solve things. Inclusive is not only for economy. Our orientation is not for money. We need to think about for all. Inclusive innovation is a means by which new goods and services are developed for and by marginal group, the poor, the woman, the disabled, the minority, etc. And also, it's the general principles is that ecocentric. Ecological concerns need to become essential part and accessible, more broadly understood to be beneficial to low-tech and social organizations, and also collaborative. Problem owners are crucial to problem solving. And intelligence is AI for science and for management. Through the online monitoring, through a bunch of big data sets, we need to find some clues and we need to we can find some clues, and we can also find some very precision parts to make the breakthrough. So inclusive and intelligent innovation may be our next approach for solve the trade-offs and also the synergies between different stakeholders and ecosystem concerns. So here is a general big map for the hydropower production goes for economy growth, and ecological concerns need to provide services for welfare of local citizens and local governments and river basin community. And we try to think about the monitoring and prediction are very important issue for us to know what will the river and reservoir complex system will be, and to make decisions of adaptive decisions. And these adaptive decisions are both made by the hydropower, river basin community, local welfare of local citizens and local governments. And you can think about long-term strategies, short-term measures, and interim plans. All these goes to the adaptive decision. So China, the upstream Yangtze watershed, are trying to set up this kind. This is what we have in our field survey, like the Yangtze simulator. You still remember?
Yeah.
The function of Yangtze simulator is doing this part, the core part.
And I have another question. Sorry, can you go back one slide, please? The River Basin Committee. Can you expand on this? Who is in charge? Who is the institutions involved in this committee?
The River Basin Committee is under the Ministry of Water Resources in China. The Ministry of Water Resources and Water Resources and Hydroengineering in China.
Is the chair?
Yeah.
Is the chair of
They're in
this
charge of the River Basin Committee, and their functioning is to prevent the floods, prevent the droughts, and also allocate the water, the fresh water along the watershed. And they have the power, or they have the right to talk to the hydro company, how many water you have to release downstream to protect the people, or how many water you have to stop upstream to protect the downstream floods, or to prevent the downstream floods. Sometimes like that.
So
here are the general.
This committee is the decision making.
Yeah, they are decision maker, and they can provide some other strategy, or they can provide some other suggestions or comments to the ecosystem. They have their branch on ecosystem research and ecosystem level evaluation, monitoring and evaluation. And they can provide some suggestions, comments, and also they can set up their own regulations to the Ministry of Eco-Environment in China. So they are a very big guy in the watershed management. And also hydro companies are also owned by a state-owned company. So why we put it here? Because they can collaborate it, and they have some trade-offs. So here you will see there are 4 other dams in the upper of the Yangtze. We call it the Xiangjia. It's encountered in 2012, and then Xiluodu. All these 5 dams are around the top 10 of the largest hydropower in the world. So currently in the upstream of China, we have 6 top 10 hydropower around the world. Yeah, including another one at the lower of the Yangtze, the lower of the Green Water System. The Wudongde, Baihetan, Xiluodu, and the Xiangjia. All these are the years of the installed capacity and also the years of impoundment. I'll show you the video. And water, energy, and what we say inclusive innovation, water, energy plus more, we need to think about the first ecosystem. There is a significant change in landscape from the Nordic to Atlantic, and we have some other native species, and also the 5 Chinese crabs and more endangered species. For instance, like these ones are endangered species. And they are trying to think about mitigation adverse effect on fish species and restore the fish habitat and support the fish passage. We have a lecture on total dissolved gas. You still remember the lady, the Dr. Fong, Professor Fong? And they are doing some kind of research to mitigate the adverse effect of the reservoir operation to on the fish species. Yeah, this is another video. And also, dams reshape the lifestyle of the local citizens and water for economy. This video is in 2017, 3 years after the impoundment of impoundment of CO2 reservoir, you will see it's a little bit similar and different, like the Yangtze, like the Green Water Dam. I think they have some voice.
Yes, voice gone.
Now we need the voice.
They don't need the voice.
We need the voice.
No,
Yes, you muted it.
Put it.
it's fly by drone. And also you'll see the 橡胶啊, so normally before the impoundment, there's no kind of cargoes here, no kind of transportation, and towns are built after the impoundment of that. The lifestyle has already changed. So the local towns are like the new town. This is used to be the kids living there. But after that, we have more and beneficial to the rest of the people.
What's the economy of the country?
Yes. The economy of growth after the damage in the reservoir.
What's about the downstream, the coastal area? What's about
The downstream,
the coastal area?
the coastal area. You mean the Shanghai?
Yeah.
Fisheries.
Question right here.
This is 2017. So you see here, this is another dam. In the upstream of the Yangtze, we call it Xiangjia Dam. It's a concrete gravity dam. But the CO2 dam is a arc dam. So it's different. So you see there's another ship lift.
Yeah.
All the water comes here green, and the other one is yellow. So there are multiple stakeholders for ecosystem restoration in the Green Water Reservoir. One is the CDG. They try to pay some money. It's not normally like a lot of hydropower industry. They try to pay a lot of money for the ecological restoration, like the Hydro-Quebec, where I used to be, and EDF. EDF have some dams in Laos. I don't know, Kiel knows that.
Here.
EDF have some dams in Laos. Nam Tong 1 and Nam Tong 2 are operated by the French hydropower company. I think it's in Vietnam. Nam Tong 2 is by the French hydropower. And they still pay a lot of money in the research, in the sometimes ecological system research. And also the River Basin Committee and local government, they try to local support, and also they can supervise how the CDG doing that. And also we have some local citizens, they need the popularization of science. They need science to know they are living in a reservoir, which is a big profit for them and also very important area for ecological restoration. And NGO, like recently along the China Green Gorges reservoir and also the upstream reservoir, the Total Nature Conservancy, they try, and also WWF, they try their efforts and methodology support and also the third party evaluation. Right now, the CDG and the TNC are working together in the tributary of the Jinsha River to remove some old dams. And they try to make the evaluation of the fish habitat restoration and fish population regrowth after the dam removal. And also we have some consulting firms for technical support, like the Mosaic from the consulting firm. And institutions and universities, like what I'm saying, we're doing the science research and also we're doing the third-party evaluation. The Chinese Academy of Sciences are right now proceeding the third-party evaluation of the 10-year forbidden fish policy, doing that. And also, this is the ecosystem restoration in nature conservancy. They are trying to make the fish spawning and also doing some activities of the old dam removal and rebuild the fish passage and restoration of spawning ground and setting up pollution control and releasing and reproduction fish. A river restoration pays more than quality itself. So that's why we have to think about the eco-hydrology is the solution. But it does not mean the natural place. We still have some kind of advanced natural place. We have to reconstruct the aquatic ecosystem by the human itself. And also, finally, the current education future perspective. The China's modernization is promoting the harmony between human and nature. This is the Chinese policy like the last year, it was set as the very important Chinese policy, which means that China's modernization is to promote harmony between human and nation. And for water, energy, and plants, we have 1, 2, 3, 4, 5, 6 connections with the UN SDGs. And water is the core for human-nature interaction. But we go back to the last slides of the eco-hydrology solution. The center for eco-hydrology means the 3 principles. The one is the science basis. It means that the pure regulation between the human and the biotype. This is the core for the pure regulation, which means that human can impact the biotype, hydrology can impact the biotype, and also biotype can re-regulate the hydrology. And the second one is the harmonization. Harmonization is the objective for eco-hydrological measures with necessary and eco-technical infrastructure. It does not mean that nature-based is the only one. We have other eco-hydrotecture infrastructure that can mitigate, that can reduce the adverse impact of biotype, and also the integration of various regulations acting as a synergistic way to stabilize and improvement of the quality of the water resources. So these are the 3 principles in 2013 to 2019 of the eco-hydrology proposed by Professor Zarwski. And what I think, this is my side, is that we have to understand the pure regulation. We have to innovate the integration, and we have to promote the harmonization. And all aspects of water treatment, let's go back to this one: water, ecosystem services, biodiversity, resilience, and cultural heritage. This is why I organized a field trip to the Buddha. You will see the cultural heritage. That's the element of culture in our workshop.
Yeah.
So anyone who wants to know about the further information about the student exchange and further activity, I'm sorry I forgot a slide last night. I made this one last night, so last slide I forgot it. So there are 2 ways for funding for students and scholar exchange. One is from the China Scholarship Council, CSCU.EU.cn, and answer. Can we access to internet right now? I will show you a little bit slides. And here's the last one. Thanks for your attention. So we are now in this
I have one question. Yes,
Okay.
Not a question, but curiosity. This 1 million square kilometer of watershed of these 3 gorge dams, yeah?
Sorry,
1 million, yeah?
Yeah, 1 million.
Yeah.
The 3 gorges dam controls 1 million square kilometers.
And there are so many tributaries contributing to its water, yeah? So how the sediment things are managed there, or how the dam managed? Because yesterday we had a guide named called Alex. He was telling everything of this dam is controlled by Chinese army or something like that, yeah?
Right now, the sedimentation issue, CFC and also the answer. Right now, you know that there are some other dams in the upstream of the Yangtze. Of the 3 gorges reservoir.
Yes.
They are a cascade system.
Yes.
So the sediment issue, the system boundary has changed due to the, comparable to the previous project design. Because in previous project design, they did not think about if there is a large cascade system. So right now, there is some kind of sedimentation in the 3 gorges, but not at the dam site. At the site where you go to the ghost city, that reach probably around 200 kilometers, the reach from the Fuling to Wanzhou. That area is the transition area from the Baltic system to the Atlantic system. That area has the most sedimentation. And also you can see in my profile that that area accumulates the carbon emission. Methane emission.
Show me the slide. It should add don't CN. No, secondly, you add more those CN. This is second one. Yes, those CN. Yes, this is starting.
Okay. Oh, you know that.
I just followed now.
Okay. Okay, these are two very, just close it. I'll show you where you can find. This is what we call the China Scholarship Council. And they accept not only for students but also for short-term scholars. And you can click the here to China. You will see that there are scholarships, a lot of scholarships for different levels, like the governmental and local government institution scholarship. For instance, ULA can apply for institution scholarship, and also school scholarship, and blah 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 blah. And also you will see scholarship application for students, but you can still open for some others. And they have Francia's webpage. And here are some programs, university programs, and also here are some news. And they may have the core. So for me, if I would like to invite some students, the primary funding sources will come to here. That is China Government Scholarship. And you can search for different kinds of course. The application guide for governmental scholarship and guidebook for ASEAN. So Indonesia, Malaysia, they have kind of specific program for ASEAN and China young leadership. For instance, Gadi and Andy can apply for this lab. And Young Excellence Scheme for China program, and also other kind of applications. This is very important. And school scholarship, enterprise scholarship, we can find some enterprise jointly funded. Sorry?
Click in there.
Okay? Okay.
Sorry.
Sorry. Confucius Institute Scholarship is taken. If your country has the Confucius Institution, I think there will be some scholarship, but it's not right now.
No, I think the problem is that you are
Yeah, I think it's,
no in the fourth, in the fifth blank box. You need to no.
yeah.
Yes.
Yes, sure.
Indeed,
Yes. Okay. So
that's it.
Yeah, you can see Shandong University CED Scholarship. That's what they call enterprise. And also we have local government scholarship. You'll see. Oh, they are different. China University of Bachelor, and also we have normally it's not within the framework of Chinese Academy of Sciences. It's kind of a different types of universities. But in Chinese Academy of Sciences, we have another types. So I think for the best one, you will see the governmental. You will see a lot. So you try to see all these types, all these different types. And for the answer, you will see that programs, fellowship and answer scholarship. These are for young talents and for mega science facilities. And for young talents, it's open for a lot of fellowship and other. And they have some kind of 20,000 yuan per month, and the round trip and travel allowance. So it's a visiting fellowship early career scientists for the postdocs or some other researchers. And senior scientists, for most of you, they will have like the 30,000 Chinese yuan per month. This will be much more higher than the China Scholarship Council, because this answer is operated by the Chinese Academy of Sciences. So these are some selection criteria, and also you can contact with me. I can send you like invitation letter or supporting reference letter and apply for this kind of scholarship. And you can come here to do open research. We are really open for research.
Good.
So this is another way for you to see some programs. And we are trying to think about the training program, because this is also the training program funded by the Chinese Academy of Sciences. And our workshop will be evaluated by the Chinese Academy of Sciences. And if we get the further funding, I believe that we have a very high possibility to get funding next year. And also we will provide the workshop, the year of next. The next year, the 2025. Or 2024 we will get funding, and 2025 we will organize another workshop like this. So this is another way. And the third one is that you will see the Chinese Academy of Sciences, the international bureau. the Chinese Academy of Sciences, they have English website, and they provided some international High Five Fellowship. High Five